and today we are starting our chapter 4, materials, metals and non-metals. So students, when we look around us, we see a large number of materials or things of different shapes, size and textures. We know that anything which occupies space and has mass is called matter. For example, chair, eraser, bucket, spoon, car, train and shoe. We can divide matter into pure substances, and pure substances are divided into elements and compounds. So, we can divide matter into pure substances and mixtures, but pure substances divided into elements and compound. And what are element? Element is a substance which cannot be split up into two or more simpler substances by usual chemical methods like heat, light and electric energy. So students, iron, oxygen, magnesium are the examples of elements, and elements can be classified into metals and non-metals and metalloids depending upon their physical and chemical properties. So students, today we are studying chapter metals and non-metals. So students, when we look around, as you can see in figure also, like computer, mobile, table, chair, almost everything is made up of metals and non-metals. So how can we differentiate these metals and non-metals? We can differentiate these materials like metals and non-metals by their physical and chemical properties. So first we will discuss about the metal. For example, iron, copper, tin, gold are the metals, and in general metals are hard and shiny in appearance. And what about non-metals? Non-metals like sulfur, phosphorus, hydrogen, oxygen, nitrogen are non-metals, and in general they are not so hard. Most of them have dull appearance. And what about metalloids? Some elements have certain properties of metals and some properties of non-metals. These are known as metalloids. For example, antimony and germanium are some example of metalloids. Now we will discuss about the metals and non-metals, and we will differentiate these as their physical and chemical properties. So now we will go through your textbook, NCERT textbook. So according to chapter 4, we can say that is materials, metals and non-metals. You are familiar with the number of materials like iron, aluminium, copper, etc. Some materials have been given in table 4.1 like iron, coal, sulfur, aluminium, copper. So we can divide them according to their appearance and hardness of material. Okay. So can you name the materials which are metals? The rest of the materials in table 4.1 are non-metals. Metals can be distinguished from non-metals on the basis of their physical and chemical properties. Recall the luster and hardness are physical properties. So we can say that most of the metals are lustrous and hard, but non-metals are dull in appearance and they are not so hard. Now we will discuss physical properties of metals and non-metals. Have you ever seen a blacksmith beating an iron piece or an article made up of iron like spade, a shovel, an axe? Do you find a change in the shape of these articles on beating? Would you expect a similar change if we try to beat a piece of coal? Yes, definitely there is a different, we can say we can distinguish these articles like coal and aluminium and iron by their physical property. Like if we will beat a coal, then it will change into, or we can say it will break into a powdery mass or into a small pieces. but when we will beat aluminium or iron, so we can say that their shape will be changed. They will directly not change into the small pieces. So this is the physical, we can say, different property of the iron, aluminium and coal. So one activity is also given, that is activity 4.1. So by this activity you can understand the property of these type of articles, that means they are different properties. So according to this activity, what we have to do, take a small iron nail and coal piece, a piece of thick aluminium wire and a pencil lead. Beat the iron nail with a hammer, but take care that you don't hurt yourself in process. Try to hit hard. Hit hard the aluminium wire also. Then repeat the same kind of treatment on the coal piece and the pencil lead. Record your observation in the table 4.2. So when you will beat iron nail, then what you will observe? You will observe that for example, metal like aluminium, copper and iron nail can be changed into a thin sheet. That means they can change their shape after beating. But instead of these things, if we will hit coal, then it change into a small pieces. So we can say that they are having the different property, and this property is known as a malleability. So we can say that metals like aluminium, copper and iron are malleable, whereas non-metals like coal and pencil lead and sulfur are brittle, because they we can say they after beating they break up into a small pieces. So this property is called brittleness. So we can say that the metals are like aluminium, copper and iron are malleable, but non-metals are brittle. You saw that the shape of iron nail and the aluminium wire changed on beating. If they were beaten harder, these could be changed into sheets. You might be familiar with silver foil used for decorating sweets. You must also be familiar with the aluminium foil used for wrapping food. The property of metals by which they can be beaten into thin sheet is called malleability. So we can say that most of the metals are malleable. And what is the meaning of malleability? We can say that the property which allow the metals to be hammered into thin sheet or foils is called malleability. For example, aluminium foil, silver foil. This is a characteristic property of metal. As you must have noticed, materials like coal and pencil lead do not show this property. Can we call these metals? No, these are non-metals, and we can say that the property due to which non-metals, if in solid state, break up into pieces on hammering is called brittleness. Non-metals are generally brittle. For example, sulfur and coal break up into small pieces on hammering. So we can say that metals are malleable and most of the non-metals are brittle. Can you hold a hot metallic pan which is without a plastic or wooden handle and not get hurt? Perhaps not. Why? Try to list some other experiences in which a wooden or plastic handle protects you from being hurt while handling hot things. On the basis of these experiences, what can you say about the conduction of heat by wood and plastic? We can say that the plastic and wood is a bad conductor of heat. That's why the handles of frying pan, or we can say cookware that we are using in a kitchen, their handle is made up of wood and plastic instead of metal, because metals are the good conductor of heat. You must have seen in electrician using a screwdriver. What kind of handle does it have and why? Let us find out. So students, by this activity we will come to know about the another property of metals. We can conclude the activity, that is conductivity of heat. So according to activity 4.2, we can say that recall how to make an electric circuit to test whether electricity can pass through an object or not, that is given in figure 4.2, you might have performed the activity with various objects in class 6. Now repeat the activity with the materials mentioned in the table 4.3. Observe and group these materials into good conductors and poor conductors. So students, here we are introducing one more property of metals, that is conductivity of electricity. So for this activity we are using here iron nail, sulfur, coal piece and copper wire. That means we are testing the conductivity of electricity of metals and non-metals by this activity. You observe that iron rod, nail and copper wire are good conductors, while rolled sulfur piece and coal piece are poor conductor. So what we have to do, we have to make a electric electric tester by connecting a cell, an electric bulb and a key of connecting wires to test whether electricity can pass through an object or not. So connect an iron nail in the circuit as it is given in the figure 4.2, and connect a coal piece also in this circuit. So you will observe that electric bulb glows when iron nail is connected with the circuit, and the electric bulb also glow in the case of material made up of aluminium and copper. The electric bulb does not glow when coal piece is connected with the circuit. Similarly, the bulb does not glow in the case of sulfur also. So we can say that what we will observe, or what we can conclude, we can say that metals like iron, copper and aluminium are good conductor of electricity, but non-metals like coal and sulfur are poor conductors of electricity. Where do you find the use of aluminium and copper wires? Have you seen wires of coal? Definitely not. So the property of metals by which it can be drawn into wire is called ductility. Have you ever noticed the difference in sound on dropping an iron sheet, plate, a metal coin and a piece of coal on the floor? If not, you can try it now. Do you note any difference in the sound produced? Yes, definitely you will note the different sound that is produced by the different type of article. So students, before discuss about the next property of metal, we will discuss the ductility and the conductivity of electricity. So by performing the activity 4.2, we can say that metals, for example iron, aluminium and copper, are the good conductor of electricity, but non-metals like coal and sulfur are the poor conductor of electricity. And the next property is ductility, we can say, because we can observe that because of this conductivity of electricity, we can say that aluminum wires and copper wires are used. So we can say that the property in which metals can be drawn into wires is called ductility. So we can say that metals are ductile also. Metals are malleable, metals are the good conductor of electricity, and metals are ductile. So in this video we will discuss only these property, and we will continue the properties of metals and non-metal in our next video. Thank you everyone.